In this video, we're going to be creating a sketch that simulates some bubbles appearing wherever you drag your mouse and then floating to the surface. So here's kind of what it might look like. So as you can see, it's almost like we're underwater. The small bubbles are floating more slowly. The big bubbles are wiggling more and floating more toward the surface a little more quickly. The reason we're going to do this is as an excuse to use a technique known as parallel arrays. So when you're programming, right, there's this concept called objects and classes where you can start to encapsulate the entire idea of some real-world thing into a bit of code. But if you haven't learned that yet, parallel arrays are a great way to simulate that. So as you can see, we've got all these bubbles on screen, but we haven't gone and created a variable like bubble x1, bubble y1, bubble x2, bubble y2 for every one of these. We don't know how many bubbles are going to appear on the screen because they appear as I click and drag my mouse. There might be only one throughout the run of the sketch, or there might be hundreds if I were to drag a bunch. So how do we keep track of the position and size of all of these little bubbles? Well, let's make a new sketch and see how we can use parallel arrays to accomplish that. So every bubble is going to have three main properties at any given moment. It's got to have an X and a Y. That just tells us where on the canvas it appears. And it's got to have a size. From there, we can run our whole bubble simulation. And so we're not just going to have an X for one bubble that we store. We're going to have an entire array of X's. This could store up to as many bubbles as we want to simulate. So rather than an X value, we're going to store an array called X's. Similarly, we're going to store an array of all the Y values. So if I were to, hard code in a couple values for now, let's say I had put 10 and 10. What this would simulate was I have a single bubble located, let's do it this way, at the coordinate 10, 15. If I add a second item, to this list, you'll see now I have one bubble that's at the coordinate 10, 15 and another bubble that's at the coordinate 20, 25. Okay, so every time I add an item to the X's list, that's the X part of a coordinate, and I want to add also an item to the Y's list so that this is a pair, this 10, 15, 20, 25 is a pair, 30 and 450 is a pair. Right? The length of these two arrays needs to always be the same. Otherwise, I'd end up with an X with no corresponding Y, or the reverse of that. So the reason we call these parallel arrays is because we keep them the same length. For every element in the X, there's a parallel element in the Y. Right? Their values don't necessarily have to be related, but this X is the X counterpart to this Y, forming a single XY coordinate. So we're not going to pre-populate these. We're going to have those get populated when we click. So we also want each bubble to be able to have a unique size. And so we'll make an array called sizes. So we're going to keep track in this sketch of three parallel arrays. So I'm going to go ahead and change the background color to a nice blue that I've copy-pasted from this HTML color code site. So when I hit play, we see just a blank canvas right now. We've created three empty arrays, one for tracking X's, one for Y's, and one for sizes. We're going to make sure these three parallel arrays always have the same length because each of them contains one of the three aspects of each bubble. So when I click my mouse, I want to create a bubble right at the spot where I clicked. So what I might do is capture my mouse X, and instead of saying that's going to be, my X value, and then creating something, I'm actually going to go ahead and say X's, the array, dot push. What that's going to do is add my X value of my mouse to this array right here. Okay, I might do the same with Y for mouse Y. So when I click, I'm going to add my X and Y coordinate, my X and Y mouse position, each to the appropriate array. Right? My mouse X gets added to X's, my mouse Y gets added to Y's, and then we'll pick a random size. So why don't we say sizes dot push, and we'll pick a random number between maybe 15 and 60. Okay, so every time I click my mouse, each of these arrays gets longer by one element because I push to x's, I push to y's, and I push to sizes. So I'm going to add to each of those. Before we start drawing to the screen, let's just go ahead and print out the contents of our arrays so that we can see what they contain at any given moment. Okay, so I'm going to print out my x's, print out my y's, and print out my sizes. Okay, so if I run this code, let's print out a little spacer between them so we can see as this is refreshing. Okay, so if I were to run this code right now, you'll notice I haven't clicked anywhere, and so x's, y's, and sizes are all still empty arrays. If I do click, let's click up near 0, 0. You'll notice I've got an x value of 12, a y value of 13, because I clicked up in that corner, and then a randomly chosen size. Okay. If I click further over, so my x is increasing, my y is staying about the same, you'll notice a second element is added. So I've got that second click position was 381 in the x, 12 in the y, and then another randomly generated size. If I click way down here, which is going to be somewhere near 400, 400 based on this canvas, a third element gets added at 392, 387, and then a randomly generated size. Now I know these sizes are long floating point numbers. That doesn't really matter, to be honest. It makes it a little less clean to look at, and if that bothers you, you can always floor this value to turn it into a random integer instead of just a random number. So now our sizes are nice, clean integers as well. And you'll see, again, when I rerun the sketch, I clicked 3 times. Now I have 3 entries in every single array. That's exactly what we want. Our arrays are maintaining the fact that they're parallel, and that's because every time I push, I click the mouse, I make sure I push one new value to every single one of my 3 parallel arrays. So that's great. We've got our, bubbles are theoretically being added to these parallel arrays in terms of their properties, but we need them to show up on screen as well. So I need some way of looping over all 3 of these arrays at once. Because these are parallel arrays, right, we're guaranteeing they're going to have the same length all the time. So as I start to write my for loop, right, we're still starting at index 0 like we always do, but when I start to determine how do I know when to stop, I might choose to use x's.length. Well, why x's? Why not y's? Why not sizes? The answer is it doesn't matter. All of them have the same length. So I could just as easily replace x's with y's.length or sizes.length, and I would get the exact same result as long as I'm maintaining the exact same length across all 3 parallel arrays. So that's why I'm able to say x's.length is my endpoint here, and equivalently able to say y's or sizes. So if I'm looping over all 3 of these arrays, right, they all have indices 0 through whatever their length is minus 1. I want to go ahead and draw a circle to represent my bubble at some x, some y, and some diameter. Now I've got to define these 3 variables, right? I can't say x's and y's. Those are entire arrays. They're not singular values that I can pass to the circle function. So I need to define x, and what that's going to be is just whatever x's holds at the index I'm currently processing. So the first iteration of the loop, it'll be x's at 0. Then it'll be x's at 1, and so on. I need to do the same for my y value, right? Remember, my x and y values are stored in 2 different arrays, but always in the same position where they coordinate. So my y value is going to be y's at I. And then again, my diameter is going to be my sizes at I. So I've gone into each of my 3 parallel arrays at the same index, at index I, and grabbed the contents of the array for that specific bubble. Now I can draw my circle. Now I'm going to set my fill to white, and for the whole sketch I don't want strokes on any of this, so I'm going to say no stroke. So if I run this, let's bring this back up. We can still see our parallel arrays are being printed. It's empty because I haven't clicked, but if I click somewhere near 0, 0 or near 10, 10, not only do I see my x, y, and size added to the arrays, the bubble shows up on screen, right? Because we're looping continuously and draw over this and drawing a circle at the coordinates that appear and the sizes that appear in my parallel arrays. So if I click over here, now I have 2 elements in my arrays and 2 circles showing up on screen. I can continue to do this, and every time I click, I see a new bubble added to the screen, and I see a new entry in my arrays. Now you might be thinking, well, I never had to worry about parallel arrays before, and I was already able to click and add a pattern to the canvas everywhere I clicked by just moving this background draw call up to setup. And you're right, we can do it that way. But what happens if I want to have things persist on screen while something is changing? So let's, for example, add our frame count, right, as our green value for the background. I'm only doing this to show that the background can change in draw. We don't have to move it to setup, and we still see our circles. Now that happened a little too quick, so let's say frame count over, 100 to slow it down. You'll see our background is changing color. Let's make it 10 times faster. Changing color over time. It is going kind of slow. Let's try this one more time. Okay, our background is changing color over time, but our circles persist. They're not getting painted over by the background because they're also being drawn every single frame. So this is one advantage, especially now that we know we want to have our circles not just appear on the screen, but move. How do we have them move? If we think back to our original example, they were doing 2 things each. They were wiggling side to side and moving upward. Let's start with having them move upward. So we're already looping over our parallel arrays. We want our circles to move upward. Well, how do I move an object upward in P5JS? I need to change its y coordinate. Specifically, I need its y coordinate to get smaller, because remember, 0, 0 is up here in the top left corner. So I want to access y as an I, and I want to make it smaller. So I'm going to use minus equals. All right. Let's start by just putting a fixed value in there. Now, you might be thinking, why wouldn't I just say y goes smaller by 5, right? Y is the value I'm actually drawing my circle at. Well, if I run this with, drawing my circle, then decreasing y, then next time I come around, you'll notice my circles still don't move. Because this y that I changed is just a temporary variable that exists for that specific iteration of the loop. By the time I come back around, it's been overwritten with whatever was still unchanged stored in y as an I. That's true even if I move this up here. Oops. Right, our y values still don't change. So instead of changing the variable y that only exists in the loop, I need to change y's at I. That's the actual contents of these arrays that we're maintaining to keep track of our bubbles. So we're going to say y's at I. We'll just have it move up by 5 pixels every frame. So now when I click, my bubbles actually drift upward. And if you can see in the array, their x's aren't changing, their y's are. Now you'll notice, even though those 3 bubbles I created are off the screen, they're continuing to get smaller and smaller y's. They just go more and more negative. For this simulation, we're going to ignore that, right? We're not going to worry about deleting bubbles when they leave the screen. Yes, we're being a little wasteful in maintaining this information on these bubbles that are no longer part of the sketch visually, but for the sake of the example, we're just going to let it slide. Okay, so that looks good. Our y's are getting smaller. Now, in the original sketch, I'm going to take these print statements out because they're slowing our code down. But in the original sketch, I had big bubbles moving faster than small bubbles. So instead of a hard-coded 5, think about how I could do that, right? I want to have a larger diameter correspond to a larger change in y. So I might just say it's exactly equal to my diameter, but you're going to notice some of my bubbles just rocket off the screen, right? A bubble with a diameter of 60 is going to be moving 60 pixels per frame. Way too fast. So maybe I want to slow that down and just divide the diameter by 10. Now you could play around with that number. I think that looks pretty good. So you'll notice as I click, a bigger bubble is going to move more quickly than a small bubble. That's great. That's the behavior I want. If we think back to the original sketch again, those bubbles didn't just move straight up in the air. To make it look a little more realistic, they also wiggled from side to side every frame. Now, with the y value, we're able to just strictly make it get smaller. But if we make our x value, x is at I, get smaller by some little amount every frame, we're going to get some weird behavior. Our bubbles now drift diagonally, right? Because they're strictly getting smaller in the X. I want them to get smaller sometimes, but then get bigger sometimes at roughly the same rate, so we stay around wiggling around basically the same center point we started at. So we don't just want X to get smaller. We don't just want it to get bigger, because that just moves them to the right instead. We want this sign to change at random. Well, a really easy way to do that is to pick a random number between a negative and a positive number. Oh, sorry. So we can say add to X somewhere between -3 and 3, right? Now when I click, you'll see my bubbles wiggle side to side. If I make these numbers way bigger, you'll see the effect is exaggerated. Now that to me doesn't look very good. It's way too dramatic and kind of spastic. So I probably would keep that to a smaller value. But now my bubbles appear to sort of wiggle their way to the surface, makes them look a little more realistic. So key takeaways here, right? We're maintaining 3 parallel arrays because the bubbles that we're modeling just have 3 properties, right? An X, a Y, and a size is enough to tell you everything you need to know about that bubble. So every time we click the mouse, we add an X, a Y, and a size to the corresponding arrays. And then we loop over the arrays, right? They're all the same length, so we use whichever one we want to use for the length in the condition here. We pull out the specific data we want. We draw our circle, and then we make whatever updates. Our size isn't changing, so you'll notice there's no line down here that changes sizes at I. We just leave that alone. If we wanted our bubbles to change in size as they rose, we could do that using the same pattern, but we're not going to for this particular sketch. Now the last thing is, when I click right now, I just get 1 bubble, but I want to see a whole flurry of bubbles. So instead of mouse press, we're going to use another similar function called mouse dragged. When you run mouse dragged, if you just click once, nothing really happens. But if you click and move, now the whole time you're dragging frame by frame, it's running this function over and over and over every frame that you have the mouse down and moving. Okay, so as long as your mouse is down and moving, we're going to see more bubbles added to the screen. That sort of concludes our little bubble simulation. I hope this has helped you understand not just parallel arrays, but the ways that we can loop over and the ways that we can add to arrays and use them to simulate some pretty cool, pretty fun things in P5.js. Thank you so much.